Hello, my name is Ashley Goodnight, and this is my Week 9 reading review for Physics 2212. This week, all of the EDX videos related to two main concepts. We were introduced to the ideas of magnetic forces and flux. In the beginning of this week's lecture videos, we reviewed the equation for the magnetic field of a single moving charge. Then we progressed to looking at the magnetic force on a single moving charge. It's important to note that in this case, Q is not the source of the B field. We end up with these equations for the magnitude. As for the direction, we use the sign of Q multiplied by the cross product of V and B, or the right-hand rule. Next, we looked at the special case of uniform circular motion. That is, when the velocity of a particle is perpendicular to the B field. We use Newton's second law of motion to set up the net force equal to the rate of change of momentum. Plugging in values for these expressions, we end up with this simplification to solve for the radius. Again, skipping back to reviewing the equation of currents as the source of the magnetic field B. Then, again, we progress to looking at the magnetic force on a short current carrying wire. It's important to note that I is not the source of B. This time we set up an expression for delta F of B. That wraps up the first video. Let's move on to the second. This lecture video began with an analogy about water flow. In this analogy, we determined expressions for volume and volume flow rate. We discovered that vector orientation matters. The example was given when the velocity is parallel to delta A. The volume flow rate actually equals 0. This leads into our first observation, that only the perpendicular direction matters, which we denote as n hat, the unit vector normal to delta A. We learned this analogy in order to easily transition into the idea of flux, which is taken by the following expressions. We talked about both electric and magnetic flux. The second lecture video wrapped up with a discussion on non-uniform electric flux, where the E field or B field and/or the normalized unit vector change. In order to solve for flux, we must change delta A to dA and solve using integrals. This week's lessons apply directly to my major, electrical engineering. At Georgia Tech, EE majors select fields or threads to specialize in. Two in specific, telecommunications and circuit technology, have required courses that build off what we're learning in this class. That wraps up my introduction to Week 9. Thank you for listening.